Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of triangle ABC equals to 13 units in length, side BC equals to 14 units, and side AC equals to 15 units. Our mission is to find out the area of this green shape. From the drawing it is very clear that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So, in the next step, I will present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 4. In the drawing we have a triangle ABC. We know that the length of side AB is equals to a unit, side BC equals to b units in its length, and side AC equals to c units in its length. In addition, the semi-perimeter of this triangle, that is to say S, is equals to the perimeter that is A plus B plus C. That is the sum of the side lengths of the triangle. And if we divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of this triangle ABC equals to A plus B plus C over 2. So according to rule number 4, the area of triangle ABC is equals to, here the squared brackets is the sign for the area, so the area of this triangle ABC, that could be any triangle, equals to the square root of S. S is the semi-perimeter, is equals to A plus B plus C over 2, times S minus A, times S minus B, times S minus C. So we can actually implement rule number 4 in our drawing. First of all, we define the length of side AB as A. And we know that A equals to 13 units in its length. We define the length of side BC of this triangle ABC as B. And we know that B equals to 14 units in its length. And we define the length of side AC of this triangle ABC as C. And we know that C equals to 15 units in its length. So I write it down here. A equals to 13, B equals to 14, and C equals to 15. In the next step, we'll calculate the semi-perimeter of this triangle ABC. The semi-perimeter of triangle ABC equals to the sum of its sides lengths, that is A plus B plus C over 2. So the semi-perimeter S equals to A, that is 13, plus B, that is 14, plus C, that is 15 over 2. 13 plus 15 is 27, and 27 plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So in conclusion, found out that the semi-perimeter of this triangle ABC, the semi-perimeter S equals to 21 units. And according to rule number 4, the area of our triangle ABC is equals to the square root of S times S minus A times S minus B times S minus C. So it is equals to the square root of S. S is 21 times S minus A. S minus A is 21 minus 13 times S minus B. S minus B is 21 minus 14 times S minus C. S minus C is 21 minus 15. So the area of triangle ABC, according to rule number 4, is equals to the square root of 21 times 21 minus 13, that is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. So the area of triangle ABC, according to rule number 4, equals to the square root of 21. We substitute 21 by 3 times 7 times 8. We substitute 8 by 2 times 2 times 2. Times 7 times 6. We substitute 6 by 3 times 2. In the next step, we will arrange the numbers here differently. We will not change nothing, but we will only change the order of the numbers without anything else. Okay? And we get that the area of triangle ABC, according to rule number 4, is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2, and again we have the square root of 2 times 2 again. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and again the square root of 2 times 2 is 2. So 3 times 7 is 21, and 21 times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. In conclusion, found out that the area of our triangle ABC, according to the new rule number 4, it is equals to 84 square units. Okay. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 6. According to rule number 6, here in the drawing we have a circle that blocks triangle ABC. Side AB of this triangle ABC equals to A units in length, side BC equals to B units, side AC equals to C units. The radius of this circle is R according to our definition. According to this rule number 6, the radius of the circle that blocks triangle ABC, that could be any triangle, is equals to R equals to A times B times C, that is the multiplication of the side lengths of the triangle by each other, over 4 times the area of this triangle ABC, that is blocked by the circle. So we can actually implement rule number 6 in our drawing. According to rule number 6, first of all, we define the radius of this circle as R. Here point O is the center of the circle. We join point O and B together by a straight line. Point O is the center of the circle, point B is the point on the circle itself, therefore OB is the radius of the circle that we will define as R. So the radius R of this circle, according to the new rule number 6, the radius R will be equal to A times B times C. That is the multiplication of the side lengths of triangle ABC by each other over 4 times the area of triangle ABC. And we already found out that the area of triangle ABC equals to 84 square units. So the radius of this circle that blocks triangle ABC, according to rule number 6, must be equal to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. The area of triangle ABC is 84 square units. Okay, so here we will divide both the numerator and the denominator of this expression by 14. So in the numerator we have 14, so 14 over 14 is 1, so we left only with 13 times 15. Over 4 times 84. In the denominator we have 4 times 84, so it is 4 times 84 over 14 is 6. So in total, after we divided the denominator by 14, we left only with 4 times 6. In the next step, we will divide both the numerator and the denominator of this expression by 3. And we will get that in the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So in total, in the numerator we left only with 13 times 5 over 4 times 6. In the denominator we have 4 times 6. So we have here 4 times 6, and 6 over 3 is 2. So after we divide it by 3, we left only with 4 times 2 in the denominator. 4 times 2 is 8, and 13 times 5 is 65. So in conclusion, we found out that the radius of this circle that blocks triangle ABC, the radius R equals to 65 over 8 units. I'll write it down here. The radius R equals to 65 over 8 units. And what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape is equal to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape is equal to the area of the circle minus the area of triangle ABC. The area of the circle is equal to pi r squared minus the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. The area of the circle is pi r squared. So it is pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So in total the area of the circle equals to pi times 65 over 8 squared. Minus the area of triangle ABC, that is 84 square units. In total, this expression equals to 207.394 square units minus the area of triangle ABC, that is 84. So 207.394 minus 84 is equals to 123.8 0.394 square units. So in total, we actually found out that, in conclusion, that the area of the green shape is equals to 123.394 square units. Repeat again, the area of this green shape, according to the first method, it is equals to 123.394 square units. So we finished with the first method. In the next step, I will present to you a second method to find out the area of this green shape. In the second method, we will do a construction, that is to say from point A, we will do a perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in BC as M. We define the length of side AM as H. We define the length of side BM as X. What is the length of side CM? From the drawing, it is very easy to see that CM equals to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. In the next step, I will copy the right triangle, triangle A and B in a new page, and we will implement on this right triangle, triangle A and B, the Pythagoras theorem. My PT is a relation for Pythagoras theorem. So actually, this is the right triangle, triangle A and B that I copied from the original drawing. AM equals to H according to our definition. BM equals to X also according to our definition. And side AB, the hypotenuse AB equals to 13 units according to what is given as the question. Again, by PT is a version from Pythagoras theorem. So in this right triangle, triangle A and B, we'll get that according to the Pythagoras theorem, that AB square equals to AM square plus BM square. So AB is 13, therefore AB square is 13 squared, that is 169. And it is equals to AM square. AM is H, therefore AM square is H square plus BM square. BM is X, therefore BM square is X square. Here we subtract x squared from this equation, equation number 1, and we get that according to equation number 1, h squared equals to 169 minus x squared. In the next step, I will copy the right triangle AMC in the new page, and we will implement on this triangle AMC the Pythagoras theorem. So actually, this is the right triangle AMC that I copied from the original drawing. AM equals to H according to our definition. We have already found out that side AMC equals to 14 minus x, and it is given as the equation that the hypotenuse AC equals to 15 units length. So in this right triangle AMC by PT is a version for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle AMC, we'll get that AC squared equals to AM squared plus MC squared. So AC is 15, therefore AC squared is 15 squared, that is 225, and it is equal to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. In conclusion, we found out that according to equation number 2, 225 equals to h squared plus 14 minus x squared. Here we subtract 14 minus x squared from this equation, equation number 2, and we get that according to equation number 2, h squared equals to 225 minus 14 minus x squared. This is according to equation number 2. While according to equation number 1, we have already found out that h squared equals to 169 minus x squared. So we have two different equations for h squared. In the next step, we create equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 equals to 169 minus x squared, and it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So actually found out that according to equation number 3, 169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. Okay, so I actually found out that according to equation number 3, 169 minus x squared equals to 225. Here we open the brackets and we get, here we'll have minus 196 minus x squared. So here we have minus times minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So after we cancelled minus x squared in this side of the equation, we left only with 169. That is equals to 225 minus 196 is 29 plus 28x. So here we will subtract 29 from this equation, equation number 3, and we get that according to this equation, equation number 3, 169 minus 29 is 140, and it is equals to 28x. Okay, so here we'll divide this equation, equation number 3, by 28, and we get that 140 over 28 is x. So x equals to 140 over 28 is 5. So x equals to 5 units. And we have already found out that according to equation number 1, x squared equals to 169 minus x squared. So x squared equals to 169 minus x squared. And x is 5, therefore x squared is 25. So it is minus 25. So in conclusion, according to equation number 1, we found out that actually that x squared equals to 169 minus 25, that is 144. So according to equation number 4, according to equation number 1, we found out that x squared equals to 144. We take a root out of this equation, equation number 1, and finally we get that h equals to the square root of 144, that is 12. Okay, so we found out actually, in conclusion, that x equals to 5 and h equals to 12 units. Again, h equals to 12 units. So you can write here in the drawing that h equals to 12 units. In the next step, we'll define the center of this circle as O. And we will join points A and O together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R, so OA equals to R. In the next step, we will extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO in this circle as point P. The radius AO is a radius, it is absolutely a straight line. And when you extend a straight line by straight line, the result AP must be also a straight line. So AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes through the center of the circle. That is to say, AP passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. So we can write here that AP is the diameter of the circle, because it passes through the center of the circle. And we know that the diameter of any circle is twice as long as the radius. The radius is R, therefore the diameter AP must be equal to 2R. So here point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle, it is equal to R. You can see from the drawing itself that the diameter AP equals to in total to R plus R, that is 2R. Okay. In the next step, we'll join points P and C together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle, and we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So I'll read rule number 7 again. According to rule number 7, is if a peripheral angle rests on the diameter of the circle, then it equals to 90 degrees. In the drawing we have peripheral angle ACB. This peripheral angle ACB rests on AB, that is the diameter of the circle, therefore peripheral angle ACB equals to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP rests on AP, that is the diameter of the circle, therefore according to rule number 7, this peripheral angle ACP equals to 90 degrees. In the next step, I will present to you rule number 8 and implement rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have two peripheral angles. We have peripheral angle ADB that rests on the chord AB, and we have another peripheral angle ACB that rests on the same chord AB. So because of the fact that those two peripheral angles rest on the same chord AB, therefore they must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. So you can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC. This peripheral angle APC rests on chord AC, and we have another peripheral angle ABC. This peripheral angle ABC rests also on the same chord AC. So because of the fact that those two peripheral angles rest on the same chord AC, they must be equal to each other. So if we define the size of this peripheral angle ABC as theta, then the other peripheral angle APC that rests on the same chord AC it must be also equal to theta. Repeat again, according to rule number 8, those two peripheral angles must be equal to each other. Why? Because they rest on the same chord AC. In the next step, we focus on the right triangle APC. In this right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle, triangle ABM, is similar to the right triangle, triangle APC. So, why those two right angles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So this is angle ABM in triangle AMB. That is equal to this angle, angle APC. Repeat again, angle ABM in triangle AMB equals to angle APC in triangle ACB. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle AMB in triangle ABM. That is equal to this angle, that is actually angle ACP. Repeat again, angle AMB in triangle AMB equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So you can write down that this angle is actually angle BAM. And it is equal to this angle, this is actually angle PAC. So I repeat again, angle BAM in triangle AMB equals to angle PAC in triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in this triangle, triangle ABM, are correspondingly equal to all the three angles in this triangle, triangle APC. Therefore actually proved that those two right angles are similar to each other according to angle similarity rule. So I write it down. Actually proved that the right triangle, triangle AMB is similar, this is the sign of similar, to the right triangle, triangle APC, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AB in triangle AMB over AP in triangle APC equals to AM in triangle AMB over AC in triangle ACP. Repeat again, we derive that AB over AP equals to AM over AC. AB is 13 over AP. AP is the diameter of the circle that is equals to 2R. And it is equals to AM. AM is 12 over AC, that is 15. In conclusion, found out that 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation, and we'll get that 13 times 15 equals to 2R times 12. So here we'll divide this equation by 12, and we'll get that 2R equals to 13 times 15 over 12. So here we divide this equation by 2, and finally we get that R, the radius of this circle that blocks triangle ABC, equals to 13 times 15 over 2 times 12. So here we will divide both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So in total, in the numerator we have to only with 13 times 5, with 13 times 5. Over 2 times 12. In the denominator we have 2 times 12. So it is 2 times 12 over 3 is 4. 13 times 5 is 65, and 2 times 4 is 8. So actually found out that the radius of this circle that blocks triangle ABC, the radius R, equals to 65 over 8 units. R equals to 65 over 8 units. We are looking for the area of the green shape. The area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared minus the area of triangle ABC. What is the area of triangle ABC? From the drawing it is very easy to see that the area of triangle ABC equals to the base that is BC times the height to the base that is H over 2. Repeat again. The area of triangle ABC equals to the base that is BC times the height to the base that is H over 2. So actually found out that the area of the green shape equals to pi r squared. So it is pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared minus the area of triangle ABC that is BC times H over 2. BC is 14 times H that is 12 over 2. This expression in total equals to 207.394 square units. In this expression, as the area of triangle ABC, that is 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC equals to 84 square units. So actually 207.394 minus 84 equals to 123.394 square units. So actually found out that in both methods, the area of the green shape is equals to 123.394 square units. Repeat again, the area of this green shape in both methods, we found that the area of this green shape equals to 123.394 square units. In the next step, I will summarize the lecture. We'll start with the first method. In this lecture, we found out the area of this green shape. From the drawing, it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. In the drawing, we have a circle. Inside this circle, we have triangle ABC that is blocked by the circle. The length of side AB of triangle ABC equals to 13 units, side BC equals to 14 units in its length, and side AC equals to 15 units in its length. Again, our mission is to find out the area of this green shape. First of all, we define the length of side AB is A and A is 13. We define the length of side BC as B and B is 14. We define the length of side AC as C and C is 15. And then I presented to rule number 4 and we implemented rule number 4 in our drawing. According to rule number 4, we have here triangle ABC that could be any triangle. The length of side AB is A units, side BC equals to B units in its length, and side AC equals to C units in its length. The semi-perimeter of this triangle ABC equals to the perimeter over 2. That is to say, the semi-perimeter of this triangle ABC S equals to A plus B plus C over 2. And according to the new formula, the area of this triangle ABC that could be any triangle equals to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of the triangle that is equal to A plus B plus C over 2. A, B, and C are the side lengths of this triangle ABC. So we can actually implement rule number 4 in our drawing. Repeat again, according to our definition, A equals to 13, B equals to 14, and C equals to 15. The semi-perimeter of our triangle ABC must be equal to A plus B plus C over 2. A is 13, B is 14, and C is 15, all divided by 2. 13 plus 14 is 27, 27 plus 15 over 2, 27 plus 15 is 42, and 42 over 2 is 21. So actually found out that the semi-perimeter of this triangle ABC, the semi-perimeter S equals to 21 units. And according to rule number 4, the area of our triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. So it is the square root of S that is 21 times S minus A is 21 minus 13 times S minus B that is 21 minus 14 times S minus C that is 21 minus 15. So the area of triangle ABC equals to the square root of 21, and 21 minus 14 is 8, times 21 minus 14 is 7, and times 21 minus 15 is 6. Then we substitute 21 by 3 times 7, and we substitute 8 by 2 times 2 times 2, and we substitute 6 by 3 times 2. Then we arrange the numbers in a different order, and we found out finally that the area of triangle ABC equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. The square root of 3 times 3 is 3 times the square root of 7 times 7 is 7. The square root of 2 times 2 is 2. And well, again, the square root of 2 times 2, that is 2. 3 times 7 is 21. Times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, we found out that the area of triangle ABC equals to 84 square units. Then I presented to you rule number 6, and we implemented rule number 6 in our drawing. According to rule number 6, the radius of a circle that blocks triangle ABC will be equal to this expression. Here, in the drawing we have triangle ABC, we know that the length of side AB is 8, side BC equals to B units in its length, and side DC equals to 3 units in its length. We define the radius of this circle as R. So the radius R, according to the new formula, or the new rule number 6, the radius R equals to A times B times C. That is the multiplication of the side lengths of the triangle by each other over 4 times the area of this triangle, triangle ABC. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks triangle ABC. So according to rule number 6, the radius of this circle that we defined as R, the radius R must be equal to A times B times C over 4 times the area of triangle ABC. And we already found out that the area of triangle ABC equals to 84 square units. So A is 13, B is 14, and C is 15 over 4 times the area of triangle ABC, that is 84. Here we divided both the numerator and the denominator of this expression by 14. So therefore, in the numerator we left only with 13 times 15. In the denominator we have 4 times 84 over 14 is 6. So in total we left only with 4 times 6. Then we divided this expression, both the numerator and the denominator of this expression, by 3. So in the numerator we have 13 times 15. So 13 times 15 over 3 is 13 over times 5. 15 over 3 is 5, so in total we have here 13 times 5. In the denominator we have 4 times 6. So it is 4 times 6 over 3. 6 over 3 is 2, so in total in the denominator we left only with 4 times 2. 4 times 2 is 8, and 13 times 5 is 65. So in total we found out that the radius of this circle R that blocks the triangle ABC R equals to 65 over 8 units. I repeat again, the radius R of this circle equals to 65 over 8 units. What is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. I repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and we have already found out that the area of triangle ABC equals to 84 square units here. So the area of the green shape equals to pi r square minus 84. R is 65 over 8, therefore r square is 65 over 8 square, so in total the area of the circle equals to pi times 65 over 8 square. Once the area of triangle ABC, that is 84 square units. In total this expression equals to 207.394 square units. Minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 equals in total 223.394 square units. In conclusion, found out that the area of the green shape, according to the first method, equals to 123.394 square units. We finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A, we do perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We define side AM as H and we define side BM as X. So what is the length of side CM? From the drawing it is very easy to see that CM equals to CB minus MC. That is to say CM equals to CB, that is 14, minus MC, that is X. So in total CM equals to 14 minus X. Then I copied the right triangle ABM in a new page and implemented the Pythagoras theorem in this triangle ABM. So this is actually triangle ABM that I copied from the original drawing. Run into the Pythagoras theorem in this triangle ABM. AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169, and it is equal to AM square. AM is 8, therefore AM square is 8 square, plus BM square. BM is X, therefore BM square is X square. So in total we found out that, according to equation number 1, 169 equals to X square plus X square. Here we subtracted X square from this equation number 1, and finally found out that according to equation number 1, X square equals to 169 minus X square. Then I copied the right triangle AMC in a new page and implemented the Pythagoras theorem in this right triangle AMC. This is the right triangle AMC that I copied from the original domain. According to the Pythagoras theorem in this right triangle AMC, AC square equals to AM square plus MC square. So AC equals to 15, therefore AC square is 15 square, that is 225, and it is equal to AM square. AM is 8, therefore AM square is 8 square, plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. So, according to equation number 2, we found out that 225 equals to X square plus 14 minus X square. Here we subtracted 14 minus X square from this equation number 2. And finally we found out that according to equation number 2, X square equals to 225 minus 14 minus X square. While according to equation number 1, we have already found out that X square equals to 169 minus X square. So we have two different expressions, so two different equations for X square. Therefore, we created equation number 3 that states that X square according to equation number 1 must be equal to X square according to equation number 2. X square according to equation number 1 equals to 169 minus X square, and it must be equal to X square according to equation number 2. X square according to equation number 2 equals to 225 minus 14 minus X square. So according to equation number 3, we found out that 169 minus X square equals to 225 minus 14 minus X square. 14 minus X square equals to 14 square, that is 196, plus X square minus 2 times 14X, that is minus 28X. So according to equation number 3, we found out actually that 169 minus X square equals to 225. Here we open the brackets. After we open the brackets, we get here minus 169 minus X square. Minus and minus is plus, so it is plus 28x. So it is minus 196 minus X square plus 28x. So we have minus X square on both sides of the equation, so minus X square we get cancelled. So in this side of the equation we left only with 169, and the other side of the equation we left with 225 minus 196 is 29 plus 28x. So according to equation number 3, we found out that 169 equals to 29 plus 28x. Here we subtracted 29 from this equation number 3, and found out that according to equation number 3, 169 minus 29 is 140, that is equal to 28x. Here we divided this equation number 3 by 28, and finally found out that x equals to 140 over 28 is 5. So x equals to 5. Then, according to equation number 1, we found out that x squared equals to 169 minus x squared. So x squared equals to 169 minus x squared. But x is 5, therefore x squared is 25. So in total, according to equation number 1, x squared equals to 169 minus 25. 169 minus 25 is 144. So in conclusion, we found out that according to equation number 1, x squared equals to 144. Here we took a root out of this equation number 1, and finally found out that h equals to the square root of 144, that is 12. So here, h equals to 12 units in its length. In the next step, we define the center of this circle as O. We join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle that we defined as R. Then we extended the radius AO by straight line until it touches the circle. We define the touching point of the extended radius AO, and the circle is P. When you extend a straight line by straight line, the result is a straight line, so AP is a straight line. AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius. The radius of this circle is R, therefore the diameter AP must be equal to 2R. Likewise, we have point O is the center of the circle, point P is the point of the circle itself, therefore OP is also the radius of the circle, that is R. From the drawing, it is very easy to see that AP, the length of the diameter AP, is equals to R plus R, that is 2R. In the next step, we join points P and C together by straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat again rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, it is equal to 90 degrees. Here we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing, we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, this peripheral angle ACP must be equal to 90 degrees. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. Coming to rule number 8, peripheral angles that rest on the same chord are equal to each other. We have in the drawing peripheral angle ADB that rests on chord AB, and we have another peripheral angle ACB that rests on the same chord AB. So because of the fact that those two peripheral angles rest on the same chord AB, therefore they must be equal to each other. That is to say, if peripheral angle ADB equals to theta, then the other peripheral angle ACB also must be equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AP. This is peripheral angle APC that rests on chord AP. And we have another peripheral angle ABC. This peripheral angle ABC rests on the same chord called AC. So those two peripheral angles, they both rest on the same chord called AC, therefore they must be equal to each other. That is to say, if this peripheral angle ABC equals to theta, then the other peripheral angle that rests on the same chord called AC, this peripheral angle APC, must be also equal to theta. Then we focus on the right triangle APC. In this right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. This is the sum of the angles in any triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we proved that the right triangle ABM is similar to the right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in triangle ABM are correspondingly equal to all the three angles of this triangle APC. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that AB in triangle AMB over AP in triangle APC equals to AM in triangle ABM over AC in triangle ACP. I repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, and it is equal to AM. AM is 12 and AC is 15. Here we cross multiply this equation and found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12 and finally found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and finally found out that the radius of this circle R equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. So in the denominator we have 13 times 15. So it will be 13 times 15 over 3, that is 5. So in total, after we divide the numerator by 3, we left only with 13 times 5 over 2 times 12. In the denominator we have 2 times 12. So 2 times 12 over 3 is 4. So after we divide the denominator also by 3, we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So in conclusion, we found out that the radius of this circle R equals to 65 over 8 units. What is the area of the green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. I repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared, and the area of this triangle ABC, from the drawing it is very easy to see that the area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the times the height to the base, that is h, over 2. Again, the area of this triangle ABC equals to the base, that is BC, times the height to the base, that is h, over 2. Repeat again, the area of triangle ABC equals to the base, that is BC, times the height to the base, that is h, over 2. So the area of the circle is pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared. So in total, the area of the circle equals to pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times h, that is 12 over 2. In total, this expression equals to 207.394 square units, and this expression equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC equals to 84 square units. 207.394 minus 84 equals to 123.394 square units. In conclusion, we found out in both methods we found out that the area of this green shape equals to 123.394 square units. Okay? Thank you very much.